A very good evening to everyone who's watching and listening this program, okay, which is a virtual airport tour conducted by the Astronomical Society of Penang, right? So just to inform you, my name is Dr. Chong, and the Astronomical Society of Penang, of course, is based in Penang. Some of you may not be aware, is on the northwestern corner of Peninsular Malaysia, the island of Penang. So we are actually south of Thailand, east of Indonesia, north of Singapore, right? And with me today to present the airport pictures for September 2021 are Mr. Lai Hong Jun, our Society of Penang member, all right, and Ms. Tui Chin, very keen astronomy enthusiast, all right, from Johor, and Mr. Sunit Singh, a student who is studying in Penang, waiting to go to university, all right. So again, a very good afternoon, good night, all right, good evening everywhere in the world. So today we'll be talking on the airport pictures for September. Let's go to the first picture for September. Let me share my screen first. Right, can you see my screen, huh?
Yes.
Airport, okay. So we start with today, 25th of September, the bubble and the star cluster. Remember, if you look behind, right below this page, you find that there are two American astronomers. You have to be nice to them because they are in the committee that will select the best picture to put in airport every day. All right. So we go to the first picture I'm presenting on the September 25th. Huh? The bubble and the star cluster. There you are. Wow. Look at this. So the bubble is on the right here, the bubble, and the star cluster is on the left. The star cluster is an open star cluster. We look at, so the bubble and the star cluster. And this is taken by a guy from Hungary called Laurent Fenges. Now, before we go into the detail of this picture and Laurent Fenges, let me give a bit of my experience. We remember we started astronomy in Penang in the 1980s. So in the 1980s, there was only one astrophotographer we know, and that is Dr. David Marlin from this Australia. That I show you here. This is the guy here we were observing in the 1980s. He was the only one, and those days don't have internet, so we saw in the newspaper, Astro magazine. So David Marlin was a professional astronomer from England, working in the Coonabarabran, the astronomy town of Malaysia of the Australia, and he worked in the AAT, Anglo-Australian Telescope. This is a telescope. Look at it. So this is today. He's about 80 years old. But that was in the 1980s when he was about 40 years old, and he's at the prime focus cage of the AAT, the 3.9 meter aperture reticulation telescope. This is at the prime focus, and he's in the cage. And so what he do is he put the glass plate, took a picture of the glass plate and developed it, and he came up with the so-called Marlin catalog of pictures. So we bought in Penang, we bought his CD, very nice. So those days in the 1980s, there was only one, and it's famous. Even long before David Peace, long before Jerry Rodriguez, it was David Marlin, all right? So his picture, we explained and showed many people in Penang in the 1980s and the early 1990s. But now, of course, we have so many people, all right? And this guy, Laurent Fenges, is from Hungary, who took this picture, all right? On the left is the star cluster, on the right is the bubble. So this explains that the star cluster is the Messier object 52, all right? So this is in the constellation of Cepheus. So Cepheus is the king of Ethiopia. So when you learn about this astronomy, you must also learn about history, mythology. All right. So this is it. And then it is actually here you have a O type star here. O means a very young star that before it perished, it blew out a bubble nebula. And this bubble nebula is quite big. It's about 20. No, let me see. So this is very big. So this whole field of view is about 1.5 moon diameter. So this is the bubble nebula. After a star passed away, it blew as a bubble and it's still expanding. Now, whenever we see our Malaysian astronomy enthusiasts, when you look through the telescope, look at the picture, there's a bubble. We say this bubble is where our Earth and solar system was born. So this bubble will expand, and the remnant of this bubble will collapse to form the next star system. So we were born from a bubble, and this, of course, nature object 52, right? So now we go to the next picture. 31st of September. Interesting picture. So this is a very nice trick shot. Voila. Okay, make it smaller. Now, taken by a guy called Hordy Koi. Now, Jachin and Sunyi, please, when you pronounce the Maasai's name, make sure you pronounce correctly. So this is a Hungarian name. No, this is actually Spanish name. So in Spanish, in Spain, it's called Hordy. J becomes H, Hordy Koi. So basically, this is a slope of a hill, and the sun is rising behind the slope of the hill. And 3.5 kilometers away, our Hordy Koi got a telescope. And this camera is attached to a telescope and took the picture of the sun rising, right? And on the sun here, you have 5 sunspots because now the sun is getting more active, a lot of sunspots. And you see here, there are 3 men there. And these 3 men are the brothers of this Mr. Hordy Koi, right? So basically, it's very nice to take this picture because you can see the objects on the ground. So you must have a compose. So basically, you must go to a distance far away from the sun such that the sun size will shrink with respect to the tree. I repeat, there are 2 objects. One is near to you, one is very far from you, the sun. And as you go further and further away from you, the size of the tree will decrease, but the size of the sun will decrease faster, so that in the end, you find that the tree is as big as the sun, right? So this is it, and this I like it. So they say that it's as if the sun is rolling down the hill, right? So now the thing is, so this place is in Alicante in Spain, which is at a latitude of 40 degrees. So you will never see the sun rising vertically in the east. No, this is a morning sky. So at 45 degrees, actually you find out the location. This is the place near Alicante. So the sun will rise actually at a 40 degrees inclination to the left. From the vertical to this direction of travel is 40 degrees. So it's rising to the left, right? So this is the sun rising above the Sierra del Cid in near Alicante, all right, with the sunspot. So nice, all right? So now 20th of September. Okay, 20th September, Linz Dark Nebula 1251. So the photographer is our Cristiano Guarco. He's an Italian astrophotographer who took it in Italy. So basically here you have a Linz Dark Nebula. So first of all, what is Linz? So Linz is actually our Beverly Turner Linz. Is an American woman professional astronomer. In 1960s, she came out with the Dark Nebula catalog. So in this catalog, many of the objects, of course, is LND, the Linz with numbers. So many dark nebulae are cataloged by her in 1960, and this is famous one. So basically, this is about LDN, Linz Dark Nebula 1251. It's about 1,000 light years away, right? Okay, so basically here, and this is the made of what? Basically, it's a molecular cloud. Molecular cloud and dust cloud. Meaning they are dust, meaning the dust on the floor of your house, at your soles of your feet now. So made of silicate and also molecules. Now the molecules can be simple molecules to very complicated molecules. So these are what? This is actually what I call a stellar nursery. A stellar nursery means if we wait long enough, then the gravity will make all the dust particles collapse to form small pebbles, and finally to form planetesimal, and finally to form planets and the solar system. So this is a this is a stellar nursery, Tadika Bintang, right? And then from the astrophysics of the problem, if you simulate it, now some people may say that now this is a very big dust cloud. Maybe 80% of the dust cloud will collapse to form the star system. No, they have simulated the astronomers that only 1% of the material in this dust cloud will collapse to form a new solar system. The 99% is wasted, not formed. So basically, our solar system, the atoms in your body, in my body, the oxygen that you breathe now, is only 1% of the protosolar nebula that successfully collapsed to form the sun and the solar system. 99% is wasted. All right. So this is our Linz Dark Nebula 1251. All right. The next one is 19th of what they call September. Okay. The title is, oh, so nice. Okay. So this is by our Damien Fish. All right. So before that, actually this kind of picture we have seen many times. For example, in the 1990s, I saw a pet from one set from Hubble Space Telescope. So Hubble has been observing Saturn for many years and collected over this. This is actually over 11 years. But actually, the whole, they call it the ring plane crossing of the Saturn as seen for the Earth occurs once every 15 years, 5 years. Ring plane crossing like that. So I repeat, in the center of the solar system is our sun. So then you have a third planet, Earth will orbit the sun, right? And then after that would be Mars, Jupiter, and Saturn. So Saturn also will orbit the sun, but further away from the Earth. So from the point of the Earth looking at Saturn, you find that sometimes the ring in the southern hemisphere is fully open. You can see the southern hemisphere very well. And then the location of the Earth with respect to the Saturn keep on changing. So you find that the rings of Saturn would be tilted less and less, and at the time it's called ring plane crossing here. Where practically you look at the telescope, Saturn don't have a ring. I remember in the 1990s in USM, in our university in Penang, there were some students who came from outside. They say, how come we don't see the ring? I said, the ring disappeared. That was the time we have the exact ring plane crossing. So from one ring plane crossing, this is the northern hemisphere, ring plane crossing, and then you have the southern hemisphere, and back again to the next ring plane crossing is 15 years. So basically, Damien Fish is a well-known, still very young British astrophotographer. He took this for many years and he compiled into one picture. All right, not only beautiful Saturn, but you can see the obliquity of the rings of Saturn. The angle of tilt keep on changing until you see a ring plane crossing. So very nice. All right. So rings and season of Saturn. So basically, if you are on the Saturn during the ring plane crossing, is what? It's a spring equinox, autumnal equinox. All right. And then you are here in the south, will be our, let's say, winter solstice for Saturn. And here is the summer solstice for Saturn. So this is beautiful. All right. By Damien Fish from the UK. All right. So I pass over now to Mr. Lai Hong Jun. Lai, for you now.
Yes. So 1 minute. All right. So can you all see my screen?
Yes, can see.
Yeah. All right. So good evening, everyone. So it's me, Lai. All right. And before I start, all right, just a simple reminder to all our friends on following our Facebook live session, Facebook page, and also our YouTube channel. So if you happen to have any questions, all right, feel free to type it in the comment section and ask us, and we will reply to you as soon as possible. All right. So let's start with the APODs on 18 September. Okay, APOD 18 September. So this is the Rubins Galaxy image taken by this Hubble Space Telescope, and we know that Hubble Space Telescope is already broken, and it will eventually be being replaced by this James Webb Space Telescope. But whether or not it's called James Webb or Webb Telescope, not sure. All right, because that day there is a session, I heard that there are some issues on the name of this James Webb Space Telescope. So what will be the final name? We are not very sure yet. All right, but of course it will be known as Webb. All right, the word Webb will be there. So back to this, Rubins Galaxy. So is known as UGC 2885. All right, image processed by Ben Holweda. Is actually a professional astronomer and also associate professor. associate professor in astronomy and astrophysics in the University of Louisville, a city in Kentucky. So it's an American professional astronomer. All right. So this Rubins Galaxy, all right, is a huge spiral galaxy. And to observe this, all right, you can find it in the constellation of Perseus. And this is, yeah, starting from last month, August is the good time for us to observe Perseus constellation. Remember last month, somewhere mid-August, right? We have this Perseid meteor shower. It's also from this constellation Perseus. It's coming out from this constellation Perseus. So, yeah, this is a star, all right, that you can observe at this constellation of Perseus. So this Rubins Galaxy is very big. Sorry, it's very big. It's about 232 million light years away from Earth, and the diameter, that means from one end to the other end, right? From one end to the other end is about 800,000 light years. 8,100 light years is about 8 times larger than our Milky Way, because our Milky Way is 100,000 light years. All right, so our Milky Way, the bar spiral galaxy, from one end to the other end is 100,000 light years, but Rubins Galaxy is 8 times, so this is 800,000 light years. Okay, and it is bigger, so eventually it will have more stars. All right, so it have 1 trillion stars. Our Milky Way, we have about 100 billion stars. Rubins Galaxy, 1 trillion stars, so it's about 10 times the number of stars as the Milky Way. So currently, this Rubins Galaxy is actually the largest spiral galaxy that we know. All right, or we had observed. Rubins Galaxy is the largest one. And also a little bit about the naming. It's actually named after this Vera Rubin. All right, this lady is a American woman astronomer. All right, and she did a lot of studies on this Rubins Galaxy. So in the year 2002, she was actually recognized as one of the 50 most important women in science by this Discover magazine. And she was academic staff in this Carnegie Institution of Washington, which is now named as Carnegie Institution of Science. All right, so she did a lot of studies in this terrestrial or extragalactic studies. So this is about APOD on 18 September. All right, next is the 15th September. So this map or this APOD is actually very meaningful, or it carries a lot of meaning. So this is, look at the title. So it says is Cyclone Path on the planet Earth. So cyclone, all right, is the common name in Indian Ocean. Over there in Indian Ocean, they call it a cyclone. But in Pacific Ocean or in the South China Sea region, we commonly known as typhoon. All right, it's actually a direct translate. In Chinese, they call it typhoon. In Taiwan, in the southern part of China, they experience this every year. All right, typhoon every year. And of course, in this Mexico and the Atlantic Ocean, they call it the hurricane. All right, so this is actually the path of the cyclone or the path of the typhoon on the planet Earth since 1985 to the year 2005. So it's about a 20 years period, and this is the number. So that means every year we have a few typhoons, all right? And even there might be a few every month, all right, at different location. So the most recent one, I think, is somewhere in early this month, if I'm not mistaken. All right, it hits Taiwan and then the southeast part of China, which is in Fujian province, that region, Xiamen, over there. So now, why I say that this photo or this APOD is very informative, because it tells us a lot of things. Okay, so first, you will realize there's a like empty region. All right, this is the equatorial region. So there's no typhoon path over here. That means typhoon will not cross typhoon will not cross the equatorial region. All right, and then usually it will move towards the north or move towards the south. So before we explain why the path is like this, so we need to understand a little bit on how typhoon is formed. So this is a little bit on fluid mechanics. All right, so fluid mechanics is very useful. All right, even in astronomy or in planetary study. All right, we still need a little bit of this fluid mechanics knowledge. So it's actually formed. Typhoon will usually form on the sea. All right, on the ocean region. So you see on the Pacific Ocean, right, the density of typhoon is very high. The density of formation or the frequency is very high. Okay, so we have the typhoon form on the Pacific Ocean. So actually it's like this. All right, when this sun shines on the ocean, all right, a lot of this water or seawater is evaporated. So it will form a low pressure center region. So as the core region is have a low pressure, so it will form like a suction. So it will suck up a lot of this water. So seawater. So this seawater will eventually like the fuel for the typhoon. So combining with this Coriolis force from the Earth, resulting from this Earth rotation, all right, so it will form a vortex. So in fluid mechanics, vortex is something very powerful. You remember this, all right? So vortex is something very powerful. So it will be continuous powered by this seawater, all right, and it will start to move towards the north. There's two reasons why it moved towards the north or move towards the south. One is because the Coriolis force. Another one is because usually when this typhoon happens, the frequency highest on the northern hemisphere. All right, the highest frequency is on July, August, September to October. So that means usually the peak, that means the highest frequency for typhoon to happen is on August and September. And then on the southern hemisphere is from December to March. All right. So you realize this is the highest frequency is during the season where changing of the season. That means from end of summer towards autumn for on the northern hemisphere, or the southern hemisphere is also the same. On December to March, which is also changing season from summer to autumn. So when seasons changing, all right, that means the equatorial region here, okay, usually the sun is directly shining around this region, right, around this region. All right, so when the sun is shining around this region, so this region it have higher temperature, and because it's season changing, so the temperature on the northern hemisphere is slowly to decrease in temperature. And then in physics we know that lower temperature, the pressure eventually will be lower. So the pressure lower, it eventually forms like a suction. So it will have a little bit of suction force to bring the typhoon towards the north. All right, so just a little bit more information about this typhoon is something interesting. If in northern hemisphere and in southern hemisphere, the rotating direction of typhoon is different. In northern hemisphere, all right, the northern hemisphere, if you observe the cyclone or the typhoon, the rotation is anti-clockwise. But in southern hemisphere, the rotation is clockwise. All right, so this is a little bit about typhoon. All right, so next we move on to the APOD on 14 September. All right, so this is a Mars panoramic 360 from Curiosity. So today, all right, today when talking about Mars exploration, we are familiar, or we always remember the Chinese Tianwen mission. The latest one is this Perseverance mission and the Ingenuity helicopter. But please don't forget, all right, we still have this Curiosity rover up there, and which is still functioning up to today, still working. All right, so this is actually image taken by Curiosity and processed by Elisabetta Bonora and Marco. So Elisabetta Bonora is actually a freelance science writer and a space image processing. All right, so she worked on this. So this is a 360-degree view. All right, and about this Curiosity rover. So before we look in this, have a simple recall on this is the Curiosity rover. Yeah, this is the Curiosity rover, launched in the year 2011, November 26, and landed on Mars about 10 months later, which is in August 2012. All right, and landed on the Gale crater. So where's the Gale crater? It's somewhere here. So if you flatten the Mars into a 2D map, then it's somewhere here on the eastern side. All right, Curiosity. So this is the Curiosity rover. So this Curiosity rover actually carries a few missions. All right, include this biological mission, geological mission, planetary process and surface radiation, and also this biological mission. So for biological mission, all right, so this is taken on the way for the biological mission. So let's look at the caption, enlarge a bit. So searching, so it says that in early September, the robotic rover Curiosity continued its ascent up to the central peak of Gale crater, searching for more clues about ancient water and further evidence that Mars could once been capable of supporting life. So on this recent Martian morning, so this is a morning, all right, sunrise in Mars. Before exploratory drilling, the rolling rover took a 360-degree panorama view, in part to help Curiosity's human team back on Earth assess the landscape and chart possible future routes. So this is a horizontal compressed feature image. An amazing vista across Mars was captured. So this is about the image. So I think that's it from me. So next I'll pass over to Sunit for the next APOD. So thank you everyone.
All right, so I think it's my time. Okay. Right, can you look at my screen?
Yes, can see, can hear you.
Okay,
Beautiful picture. Wow, wow, wow.
Yeah, this is quite a beautiful picture, and this APOD has a title of Night Sky Reflector. And by the way, this is the APOD for 13th of September. And this picture is taken by Egon Filter. So basically, Egon Filter is a photographer. Yeah, mainly it's a photographer from Brazil, and this picture is taken from Monsteras, which is located at the very quite south of Brazil. Yeah, and first of all, when you see this picture, you can see that there's basically 3 galaxies we're looking at. So you'll be wondering, there's 3 here. So first, the galaxy here is a small Magellanic Cloud, and the second galaxy is a large Magellanic Cloud, which both they are the dwarf irregular galaxy. And the third galaxy you can look at is actually our galaxy, which is the Milky Way, and you can see the central Milky Way band over here. Yeah. Okay. So what makes this image quite interesting is that you can see the reflection over its little pond over here, and there's a guy holding a quite big mirror and reflecting over the night sky. So right now, you can look at the guy over here. He's taking a mirror, and this mirror is actually showing the sky, which is not visible to this point of view, to this camera point of view. So basically, right now we're actually looking at 2 sides of the skies. You can see in front of the camera and behind the camera through this mirror. So in this mirror, you can actually see that there's some dust clouds at the central band of this Milky Way over here, and this bright star over here, and actually I cannot say that this is a star. this is actually a planet, Jupiter, which is the largest planet in our solar system. And you can see it's actually quite bright because Jupiter is quite bright. Yeah. And then when we look at the pond over here, you can see that there's also all these objects reflected by the night skies. And you can also observe that these stars are quite blurry. So there's this one possibility that the water in this pond is actually moving quite slowly. So basically, I think that when this guy, he want to take the picture, he had to walk to this pond. So when he walk, he will create some motion in this pond, so the water might move a bit and make this image reflected at the point is quite distorted and blurry. So this picture is also one of the first place in a competition, which is the Capture the Dark contest, organized by the International Dark Sky Associations. And what's interesting about this is that there's a category for the mobile photographers, and one of our Malaysia's quite renowned astrophotographer, which is William Chin, and he got second place in this contest, which in the category of the mobile photography, using a mobile phone to take the night sky. Okay, so for this guy, Egon Filter, he also used one camera, and he took basically at this one location and also the same night. So means that he cannot take picture between different nights. Yeah. So this picture actually consists of 16 images stacked together to make this one very beautiful image. And so this is it for the 30th of September APOD. So next I'll move on to the 12th of September.
Wow.
Okay, wow, yeah. It's also another beauty of the universe. Okay, so what we're looking at right now, I'll show the full picture. Yeah, it's quite big. Oops. So quite big picture. And this picture has a title of the spiral aurora over Iceland. So basically, this picture is taken by David Netchie, which is a computer scientist. So you might be weird why a computer scientist want to be taking photo of this instead of typing codes or something like that. So astronomy is basically a hobby, and it's quite astrophotography like this is also a hobby for everyone. A lot of people like to take beautiful images like this. And so yeah, anyone can be an astrophotographer if you have the passion. Okay. So this David Netchie is basically a computer scientist from Italy, yeah. And you can see the Aurora here is quite this area here is quite concentrated. So basically this is a spiral aurora. And about Aurora, how it was formed, so we have to know that when the sun, it will emit a lot of charged particles, and then the charged particles will travel to our Earth. And then when it travels, it will strike our Earth's magnetosphere, and then all the particles will be guided around the magnetosphere, and eventually these charged particles will arrive to this northern pole, more to the northern latitudes or southern latitudes of our Earth. So this is why that in country like Malaysia, which is located at the equator, or maybe China, which is about middle latitude of the Earth, yeah, you can't really see observe aurora, because all the auroras are concentrated either the north or south pole. So this is why they're also called as the northern lights or southern lights. Yeah, so if you want to see an aurora, you can maybe travel to Scandinavia, Canada, Alaska, Greenland. You can observe all those aurora over there. And in fact, this was taken at Iceland. So we can actually also predict when the aurora is going to be, when there's a lot of aurora, or when there's only a bit of aurora. So when we take a telescope with filter, when we look at the sun, when there's a lot of sunspots, we can know that the solar activity is quite high, and so that when there's a lot of sunspots, it will emit a lot of these charged particles to the Earth. So when there's not a lot of sunspots, so means that the aurora will be fewer at the Earth. So when the particles strike the Earth atmosphere, they will excite all the oxygen atoms, which when it excites the oxygen atoms, the electron in the oxygen atoms will jump between energy levels, and when it jumps to another energy level, eventually it will give off a certain wavelength of light, and so when it strikes oxygen atom, it will give a light of about maybe this green and red color. So you see this aurora, and we can also see some clouds. So basically, aurora is not like a cloud, and you can actually see there's some stars behind the aurora. So unlike clouds they completely block off our visions when we look at the stars. So aurora, it don't really block off all of the visions. You can actually see through some stars, and you can actually see here there's some stars they are not just as bright as usual. They will be a bit more dim and faint when it's blocked by the aurora. Okay, so this is it for the 12th of September APOD, and I'll move to next, which is the 10th. Okay. So this is a APOD for 10th of September, and you can see there's a comet, which is quite rare to be taken. So this image is taken by Rolando Liguisti, and he's actually an Italian, and they also call him the comet guy because he's a comet researcher from Italy. And in fact, this picture over here is taken from Italy. Yeah. And so it was also, this comet researcher is actually, he used some equipments from this CAS and Kairos project. And Kairos project stands for Cometary Archive for AFRO. And AFRO is basically the products of this dust albedos. And CAST is basically Circular Astrophilae Taumaceans, which is at Italy. So in this image, we can see that there's a comet over here, and this comet also have a name called Churyumov Gerasimenko 67P, and this is a period comet. So period comet is like Halley's comet, means that this comet will keeps orbiting the sun in a elliptical orbit. And when we talk about this, we have to know a bit about the Kepler's second laws of planetary motion. So when this comet is approaching the sun, the velocity of the comet will be getting higher and higher. And so right now, actually, this comet is also quite near to us and near to the sun. So actually, it's approaching the perihelion. And so when this comet, when it leaves the sun, the velocity of the comet will be getting slower. The comets will travel more slower. And these comets will orbit around the sun, and one complete orbit takes about 6.5 years. And so that this comet is quite more. We can see this comets more often, not like Halley's comet, which completes one orbit for about. One orbit takes about 76 years. And so this comet is actually also studied by one of the spacecraft called Rosetta, which is this one. This spacecraft was launched by the ESO from 2004. Yeah, and this spacecraft is one of the main mission of this spacecraft is actually to study this comet, the 67P, and this is a higher definition image for this comet. And you can see that this comet has made of two lobes. One is about 4 kilometers in length, and one is about 2.5 kilometers. And so this Rosetta was this spacecraft took about I think 5 to 6 years, mainly just to study this comet. And I can say that this comet is also one of the best comet ever studied by our human race until now. So this comet, for the Rosetta, eventually about 2015, because this comet at that time was not very near to the sun, and so the Rosetta for the spacecraft, it will not receive enough sunlight, and hence it cannot power up the heater of the spacecraft. So the ESO, the committee, they decided to crash land the spacecraft onto this comet. And because this is actually quite dramatic, because the spacecraft now, when it collides with the comet, the spacecraft and the comet is also traveling towards the Earth. And so when it collides, the researcher can also let the Rosetta to transmit all the data back to Earth. And so it's quite dramatic, because when all the data was completely transmitted back to Earth, the Rosetta is about 10 seconds before impacting the comet. So basically 10 seconds before the impact, all the files were successfully transferred back to Earth, and then after 10 seconds, the Rosetta just crashed onto this comet. So as we see from here, we cannot see the comet quite good because of this halo of this comet. So when we see a high definition, it's actually quite small, and it's not this big. And for a fun fact, basically, we right now, legit right now, we can actually see this comet at the night sky over Penang or over Malaysia. Actually, we can see it right now. It's just above us, and it's located at the constellation of Pisces Austrinus. So after this info session, you can actually go out and try to use a telescope and observe this comet. Yeah. Okay, so I think this is it for this 10th of September APOD, and I'll move on to my last picture, which is the 8th of September. Okay, so this is also quite a very, very big picture. And if I zoom out, yeah, this picture is quite big. You can see there's three galaxies here and some nebulas over here. So I'll read the title first. So yeah, this picture is called The Deep Sky Towards Andromeda, and it's taken by Stefan Zegenbaum, which is a German astrophotographer. Yeah. So when we see this image is quite big and very, very big. And this image is also the degrees, the angle of this image is about 40 degrees. So means that from here to here at the night sky is about 40 degree in difference. So 40 degrees is quite large. And to take such a large picture like this, you need quite a very long exposure time, and you need a lot of time to capture this image. So this guy, Stefan, he actually took this image from 2018 to 2021. So it took him about 4 years to take this whole high definition image. Okay, so in this image is actually taken at Pausing, which is a small town located at the eastern Germany. And in this image, we can see that there's 3 galaxies. So one galaxy is here, M33, the Triangulum Galaxy, M31, Andromeda Galaxy, which is the closest galaxy to Milky Way Galaxy. And the third galaxy is actually this little galaxy over here, and it's the M100. And then next, you can see there's two nebulas over here also. One is a C12, and another one is the SH2126 nebula, which is a nebula from the Sharpless catalog. And for this Sharpless catalog, it was completed by a guy called Stuart Sharpless. And this catalog is basically a list of all those H2 regions objects, and it was completed in the year 1959. And so you can see there's these three galaxies. So Triangulum Galaxy, Andromeda Galaxy, and our Milky Way Galaxy that makes up the three major galaxies within our local group, which our local group basically contains about 30 galaxies, or maybe more than that. But Milky Way and Triangulum Galaxy and Andromeda Galaxy, all these three galaxies are the major galaxy in this local group, and others, they are just small and dwarf galaxies. So all these spiral galaxies, they will dominate our small clusters, and then for the large cluster galaxies, they mostly contains very, very large elliptical galaxies. So how do very large elliptical galaxies form? So right now we'll talk about this Andromeda Galaxy and our Milky Way Galaxy. So actually right now, this M31 and our Milky Way galaxies are in a collision course. And right now, Andromeda Galaxy is about 2.5 million light years away from our galaxy, Milky Way Galaxy. And maybe it will take about 5 billion years. Maybe the Earth has already been disappeared from this solar system, and the galaxy haven't even collided with our Milky Way Galaxy yet. So it takes a lot of time because the distance between the Milky Way Galaxy and the Andromeda Galaxy is quite large. And so when Milky Way and the Andromeda galaxies, when they collide to each other, and they will merge into one very large elliptical galaxy. So this is how a elliptical galaxy will be formed. Okay, so I think this is it for me, and I'll pass it to Jekin.
Thank you, Sunit. All right. So can everyone see this?
Yes, can see.
Okay. So just to continue from what Sunit is saying just now, the Andromeda Galaxy is going to collide with the Milky Way in the future. But currently, we can see what's going to happen to us as well. So this is a photo called NGC 520, colliding galaxies from Hubble. So it's a Hubble image processed by William Osling, which is a US astronomy enthusiast. Now this is a very large photo, and it's a very beautiful one because these two galaxies are quite hidden behind the dust. You cannot really see. I cannot even tell where is the galactic nuclei in this galaxy, but you can actually find these two galaxies in the Pisces constellation tonight. So apart from one of the nebula that Sunit mentioned, tonight at around 1 a.m., you can look towards the Pisces, which should be transiting at the meridian, and you can find it roughly in this direction. But it's gonna be a very hard challenge because Pisces is a very dark constellation, and it is next to a very faint star as well. But for those who are willing to take this challenge for NGC 520, wish you good luck. hopefully you will see something as beautiful as this. But this is only available through processing, right? Maybe if you use your naked eye, it will be more like a gray smudge, a very faint gray smudge. But if you process it using an astrophotography software, you'll get something amazing like this red color, beautiful spine here. All right, so next we have Firefly Milky Way over Russia. So this photo is a photo of coincidences because there is a lot of things here that can be an APOD picture at its own. So in this picture, we have the Milky Way, very beautiful as always. We have Saturn, and we also have a satellite trail over here. And apart from that, this Russian photographer, Mr. Anton Komlev, he also photographed the green air glow, which is only possible to be seen in very, very dark places. And to add to that coincidence, he even photographed a firefly in the forest. So this is a very, very complex picture. A lot of activity is happening inside this picture. Really beautiful. And this picture is actually a 3-frame panorama. So it's actually a composition of 3 frames. And we also have Altair, which is from the constellation of Aquila, and it's facing to the south because of if you look at the orientation of the Milky Way and Aquila, this is actually the southern direction. And to talk about the green air glow, so where does this come from? Now, the green air glow actually doesn't have a lot of connection with the sun. Even if you minus out the effect of the sun from the far side of the Earth, there will still be green air glow because the green air glow is from the mechanics on the top of the upper atmosphere. So there's a few reasons behind this green air glow. One of the reasons is because of the cosmic radiation from outer space, not only from the sun. It could be some cosmic radiation from another galaxy or a rogue star. All those cosmic particles will interact with the upper atmosphere, and then they will release this energy of their interaction in the form of this green light. And another theory is that some of the upper atmosphere they get decomposed during daytime, and at the nighttime their energy levels go down because there's no sun, and then they recombine to give this green air glow. So there's a lot of different mechanisms behind the green air glow, and it's also the reason why we cannot achieve perfect darkness. Even if you go to the darkest place on Earth, exactly at 12 a.m., when the sun is directly 180 degrees behind you in the nadir, you cannot achieve total darkness because of the green air glow. So that is one of the reasons we need space telescopes as well, because ground telescopes are also affected by green air glow. You cannot measure to, you have a limit of precision that you can measure because of the green air glow. But once you use a space telescope like Hubble, you don't have this limitation and you can detect fainter objects with greater precision. It's a very beautiful picture. So next we have September the 3rd, NGC 7023, the Iris Nebula by Satwan Kumar. Okay, so this might look like a typical nebula picture, but if you look closely here inside, you can see hints of red inside the nebula near the star. So what the astronomers suggest is that this red light is given from the dissociation, the photo dissociation of the molecules inside it. It only happens in a very hot environment. So yeah, the central filaments of the reflection nebula glow with a faint reddish photoluminescence because of the photo decomposition effect. So, and then this nebula is also special in the fact that astronomers detect PAH inside there. So PAH stands for a complex organic molecule made of carbon. It is only available inside this hot, dense stars. The other compounds cannot be found here, but PAH is a distinctive trait of these hot, dense stars. So these PAH are known to survive in this hot, dense environment, and it could be it is actually a source of interest for astrobiologists because they think it provides the building blocks for life as well. And you can find NGC 7003 in the constellation of Cepheus, but it is quite far north. So if you live near the equator or further south, you might need to have a hard time finding it because it's quite close to the horizon. It's a very beautiful picture, and you can see the great contrast between the young star and the future of what this nebula holds. Maybe it will form a star system with life, with all the PAH. So let's wish this nebula good luck in the future. And then come to our final picture of the day. For September, we have two dancing ghosts. Okay, so this is taken by Professor English, and we also have Ray Norris here, which is Australian astronomer. And this is actually special for Ray Norris because it is taken by the Australian telescope, it's the Australian Square Kilometre Array Pathfinder. So what is causing these ghosts? These are not nebulas, these are not clusters. These are actually the light coming from a mechanism from the active galactic nuclei, or AGN. So if you see carefully, there's actually two galaxies here with supermassive black hole inside that shoots out these relativistic jets. So these are the characteristics of AGN, the active galactic nuclei, where their accretion disk gives them enough energy to shoot out jets of super highly charged particles. So these particles are charged, right, such as electrons, protons, etc. And the AGNs also have a very strong magnetic field. So when an electron encounters a strong magnetic field that is perpendicular to its velocity, then they would have a synchrotron radiation. And this is the mechanism that causes these two dancing ghosts. But if you know about AGN, you notice that all of them shoots in a straight line. So why does these two become ghosts? Like, why they come together? So this is actually because scientists suggest that this is because of the intergalactic winds. So there's involved large scale of intergalactic winds. So where does this intergalactic winds come from? So there's no air in space, of course. These winds are actually streams of particles coming from supernovas happening anywhere in the universe. So in this region, they seem to be suggesting that there is a large scale interstellar wind going on. Right? There has been a few supernova in the region that gives out all these particles at high energy that pushes these electrons together, come together like this. So It's a very symbolic picture. They really look like two ghosts dancing together, holding hands like this. And yeah, I believe that ends our. Oh, and one thing, the astronomer of the astronomy picture of the day has a very good sense of humor. If you click on the amorphous blobs, it will take you to a picture of kittens. So very good humor, NASA. I like it. So yeah, that ends our picture of a day for this month. So, Lai, back to you.
All right. So thank you, Justin, for the APODs for September. So let's see whether we have any questions on our Facebook and YouTube channels. So any questions?
I think like someone from Korea like your typhoon explanation, YouTube.
Is it?
Yeah, there are two comments on your typhoon explanation. They like it. Korea.
Oh, I just realized I'm not on YouTube.
YouTube, yeah. Right from the beginning,
forgot.
you explained about the Korean reports. I already saw that already. The Korean
I
guy.
forgot. I forgot to open the YouTube. I just opened the. I just realized that I did not open the the YouTube.
I got one question about the typhoon.
Yeah.
You say that in the northern hemisphere, the eye of the typhoon rotates anti-clockwise, and in the
Yeah.
southern hemisphere, the eye of the typhoon rotates clockwise. Why? Why in the northern hemisphere the eye must rotate anti-clockwise? Of course, it's related to the coronary force. Always related to it.
Oh yeah. Okay. I
But this is always a curiosity. You rotate anti-clockwise. Why?
Yes. Wait. Yeah. Actually, I saw the explanation before about the vortex. They actually did this. They actually did this experiment in I forgot which country already. On the equator, on the northern hemisphere, on the southern hemisphere. So they make a sink, and then they observe the what they call the direction of the vortices. So that experiment is interesting. If I'm not mistaken, if I still remember, all right, it's something to do with the with the what? With the Earth rotation, right?
Yeah. Never mind. Allow me to comment,
Yeah, please.
It's always related to the coronary force, which is our Gaspar, what they call the coronary French mathematician. They wrote a paper in the 19th century. So basically, is that the whole idea of this typhoon because the Earth rotates. Because on the Earth rotation, everywhere in the Earth's surface, except for the equator, there's a coronary force. And if you go to the mathematics, the coronary force depends on the sine lambda. Lambda is the latitude of the place. So in Penang, it's 5 degrees north. So sine lambda, sine 5 degrees is very small. So in Penang, the coronary force is very big. In other words, at the equator, the coronary force is 0. Penang, very big. So near the equator, very big or no coronary force. That means, that's why you said just now, you never see the typhoon cross from the northern hemisphere, cross the equator to the south. It's not that they cannot cross. By the time they reach the equator, the coronary force will have died down. That means the typhoon will have died out already, destroyed itself, 0. So it cannot cross the equator. And then why is it anti-clockwise in the northern hemisphere? Because the idea is that if you apply the coronary force, the Earth rotates. From Polaris looking down, the Earth rotates anti-clockwise. So because of that, you look anywhere in the Earth's surface, there's a local vertical. So whenever the wind blows in the northern hemisphere, the wind will be deflected in the northern hemisphere to the right. So in the southern hemisphere, the wind is blowing over a long distance. The wind will be deflected to the left. Why? Coronary force. So now in the northern hemisphere, it deflects towards the right. And here another wind is coming in. So how does the wind just occur? Hot air, the sun is hitting the Earth's surface because hot. So the the hot air rises. So the cool air from outside must rush in to fill it in to create the wind. So as they travel from the high pressure to low pressure in the northern hemisphere, deflect to the right. Here also to the right, always to the right. So in the eye, it will automatically anti-clockwise. In the southern hemisphere, when it blows, it's always deflected to the left. To the left. So when it comes to the eye of the storm, it will be clockwise. So that's it. So the higher, the further north you go, from Penang, you go to Thailand, Philippines, China, Japan, the corollary force is stronger, right? Because sine lambda is the highest in the North Pole. But why is there no typhoon in the North Pole? So in other words, the corollary force is necessary for the typhoon, but it's not sufficient. The other thing is the shape of the land and so on, the land, the continent. But what you call it, the higher, further up north you go, the corollary force is bigger. That's it. So in other words, how to eliminate the corollary force? The Earth don't rotate. You stop the Earth from rotating. Sine lambda is no more there. No corollary force. So if the Earth is not rotating, whenever you have hot air rises, cold air will come and stop. There's no rotation at all. So just like the Jupiter also got the Great Red Spot because the Jupiter spin fast, That's why the Great Red Spot is an anti-typhoon, anti-cyclone. Because on the Earth's surface, center of the typhoon, low pressure, outside high pressure. But Great Red Spot in the center of the Great Spot, high pressure. Outside is low pressure. So it's an anti-cyclone. So how to, let's say you want to destroy the Great Red Spot. No Great Spot, Jupiter stop rotating, but not easy. So if there's no rotation on the Earth's surface, no typhoon, nothing. Because the Earth rotates, that's why. Yeah.
Just to add on a bit, another reason why on this North Pole we don't have this typhoon is, yes, the fact is the Coriolis force is very strong, is stronger at the North Pole. But then in terms of temperature wise, it does not reach the requirement for the formation of the typhoon. That means the temperature is not high enough, so not much seawater is evaporated into the typhoon. So that's why in northern hemisphere, in the North Pole, we don't experience typhoon. So actually, in Malaysia here, we are safe.
Yeah. Of course, if we ask, is the Earth's rotational motion, the energy of Earth's rotation that caused the typhoon? Answer is no. It's the energy from the sun. The energy, the sun will heat up the Earth's atmosphere, the air will rise and cause the wind to blow. So it's the driving force of the typhoon in the Pacific Ocean, the cyclone in the Indian Ocean, the hurricane in the Atlantic Ocean is because of the sun. But the Earth's rotation must be there also for the hurricane or the typhoon to occur. But the driving force is the sun, energy from the sun. Yeah. So any other question?
When I see this photo, the first thing come to my mind is we should ask Yong Lip to be here for this photo because he's in Taiwan. Yeah. He might experience couple of typhoons.
Yeah. For example, you mentioned just now, I saw a picture, the typhoon Chandu. I thought maybe Yong Lip would have experienced it.
Yeah.
Because it's seen not the whole Taiwan, the southern part of Taiwan, Hualien, Tainan area is the so-called Typhoon area, Lorong Typhoon, where the typhoon before it hits China, Fujian province, it passed through southern Taiwan. Yeah.
Yeah. So I don't see questions from our Facebook site, and also no, we don't see questions on the YouTube site. So yeah.
So Michael, we can end now. Maybe before that we okay. What's the question, Michael? Why you want to answer? Cluster. Yeah.
In terms of physics, yes, it will. It will be the wind or the wind velocity eventually will be higher. But then this is not the only factor that contributes to how severe the typhoon is or the category of the typhoon. It's not solely depends on the Earth rotation speed. Right? There are many other factors. All right. So Dr. Chong, any add on?
Yeah, let me add on. Okay, first of all, is the strength of the strength of the typhoon or the occurrence of typhoon because of sign lambda. And the person asked if the Earth rotates faster. So according to the formula, corollary force one, the rotation speed is omega dot lah. Omega dot is the angular. No, sorry, omega. Omega is the angular velocity of rotation of the Earth, right? So the corollary force, the effect of the corollary force is also depending on omega. The bigger the omega, the faster the Earth rotates, the stronger is the corollary effect. So if the Earth rotates even faster, then the corollary effect will more. That means the typhoon will be stronger. For example, we know that Jupiter is 10 times bigger than the Earth in terms of diameter. And yet Jupiter makes one rotation in 10 hours. It's 10 times bigger in terms of the linear distance, but it rotates 2.5 times faster than the Earth. No, Earth rotates once in 24 hours. No, Jupiter rotates once in 10 hours. So that means Jupiter's typhoon, the greatest spot, the winds must be very, very strong. You can go and make a calculation. I have a feeling it's like hurricane wind blowing there for a few hundred years. So yes, because if the Earth rotates faster, then the effect of the typhoon will be worse. So one of the things, this is my wild comment. If anyone is caught in a typhoon, you want to make the typhoon disappear, please say, please, Earth, stop rotating. Stop rotating. Once you stop rotating, sign lambda is sign zero lah. No more corollary force, no more typhoon. Right there, the Earth don't rotate, then no more typhoon. Typhoon is destroyed. Yeah.
Yeah lah, but then just like I mentioned just now, the fact is not only the Earth rotation speed lah. So there are other factors contributing to the formation of typhoon. So for example, the temperature also plays a very important role. All right, if it's not hot enough, not enough seawater is evaporated, so not enough seawater is there to fuel the typhoon. So eventually it will become weaker as well. All right. So
Usually,
typhoon is a very complex science. All right. So until today, there are still many research conducted on typhoons, on cyclone, on typhoons. Right. It's combination of astronomy, atmospheric science, fluid mechanics. All right. So yeah, we have to put all together, combine all together, integrate all together. Then only we can thoroughly understand each typhoon. Yes, Dr.
So
Choi?
actually, the extension of corollary force is not only on the flowing of air in the Earth's atmosphere, the wind, typhoon, cyclone, and so on. Other things like this. For example, you can know that, for example, I've taught this course before. You look at the mouth of the Perak River, Sungai Perak, as the water flows from the north to go out to the Straits of Malacca at Bagan Datu. So imagine the width of the Perak River is at that time we say 800 meters lah. So as the water flowing into the sea at Bagan Datu, again because of the corollary force, the Earth is rotating under the river water, so the river water will be deflected towards the right. That means the right bank of the Perak River at the Mount River, the water level there should be higher than the left bank. This is the case. It can be found because of the effect of corollary force. Or imagine you are somewhere in Iceland, there's a sheet of ice, frozen lake, very still. You throw a bowling ball and the bowling ball can go forever and forever. Imagine the ice is forever. So as the ball travels on the surface in the northern hemisphere, it will be deflected towards the right. So if you follow, so what will happen to the bowling ball you throw it on the ice, right? Imagine it's a big ice field. The bowling ball will go in a huge circle, how many 100 kilometers, and come back to you in a circle. Why? Corollary force lah. This is what is a can. Or you can make a calculation. Imagine there's a big iceberg that broke off from the Antarctic ice shelf near the North Pole. They broke off. So imagine an iceberg as big as the Penang Island is now moving in the ocean, because it's blown by the wind and moving at quite a fast speed, say 1 kilometer per hour moving, but it's the size of Penang Island. Then suddenly the wind stopped blowing. So what happened to this big ice block floating in the ocean, traveling at 1 meter per second, what happened? Coronary port, the iceberg will not go straight in a straight line. No, it will go in a huge circle and go round and round and round. That's what we can do. And the other one is when you apply this classical mechanics on coronary port, it will include another force called the centripetal acceleration of the Earth. Remember, when the Earth rotates, it creates a coronary force. Another one is because of the centripetal force. If you're standing on the Earth, let's say this is the Earth rotating like this. So there's a centripetal force want to pull you away from the Earth's gravity, So that means when you are on the Earth's surface, we are near Malaysia, near the equator, where the centripetal acceleration is higher, you are actually lighter. Because the centrifugal acceleration pull you away from the center of the Earth, like this. And also, this is that on the equator, imagine you have a kind of a plumb line, a string with a stone here. Question, will the plumb line start on the top, reach the plumb, and go to the center of the Earth? Answer, no. But Earth is rotating near the equator, the plumb line is tilted towards the east, deflected to the east. And you have people that do the experiment, they can measure that. Imagine in Comta, I draw a big plumb line, no air is blowing. So the plumb line is deflected towards the east a bit, and it's don't know how many arc seconds. Because the Earth is rotating. So how to stop the deflection of the plumb line? Earth don't rotate. Then from the plumb line, you go to the center of the Earth. So there are two effects involved, coronary force, and the other one is centrifugal acceleration. These two. Yeah. So okay, So Michael, can we end? Thank you, Michael. Okay, So don't go yet. Jachin and Sunit. Lai, you want to make some oral comment?
Yes. So I think that's all for APOD session for September. So before we end our session, all right, just a little bit of advertisement on what we will have on next month. So next month, yes, we will have our Astro Cafe session on the second week of October, and then also we will have our APOD session on 1 month later, which is on 30th of October. All right. I'm sorry. The Astro Cafe section is on 16th of October, right? Yeah. And what are we having for our Astro Cafe session? We haven't decided yet. Yet to decide. Yeah. So yes, and also we are conducting this astrophotography competition by ASP site. So the deadline for the competition submission is on 31st of October. That means you have about 1 month's time. So yeah, we have a lot of prizes, a lot of good prizes for the astrophotography contest, and selected winners. The photos from selectors photos from the winners will be put in our yearly table calendar next year, sorry, in 2022. So yeah, everyone are welcome to join us. All right. So I think that's it.
One more I add, Lai, I think in October we are going to invite Jachin and Sunil. Listen, our own Malaysian meteorite collector, a girl, Sabrina Chan. Okay. So our member Derek will interview Sabrina, how she started this hobby of collecting meteorites. So during the session, she's going to show us how her meteorite look like. All right. And she's quite knowledgeable about meteorites, And meteorites have a lot to do with astronomy. Right. So I think it's in October the 23rd, Saturday. Sabrina Chan, our own Malaysian meteorite collector, will be interviewed.
Yeah, and also tomorrow we will have this photography imaging workshop from us, and we have invited William Jin for the workshop as the instructor of the workshop. So is that workshop still on, Michael?
Yes, on. I already download all the files already.
So yeah, everyone is welcome to join us. So yeah, I think that's it for the APOD tonight. So thank you, everyone. Thank you, Dr. Chong. Thank you, Sunit, and thank you, Jachin. And we wish every of our audience in our Facebook channels and also in our YouTube channels and also Facebook page. Have a good night and have a wonderful night. See you next
We've
month.
been
Bye
there.
bye.
We've been there. Okay.